This is going to be a lesson on using scale factor, how to find the scale factor given two objects, or how to find the size of another scaled object given the scale factor. Reminder that the formula scale factor equals the dimension of our something on our model compared to the dimension of the corresponding part of the original. Okay, so scale factor is model over original. For our first example, we want to find the scale factor of the reduction. Because it's a reduction, we know the original should be the larger shape and the scale diagram will be the smaller shape. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So original equals 10. Our scale diagram 1, 2, 3, 4. Let's call it our model. Okay, I used the diameter for the original and the diameter for the scale diagram, so I have corresponding dimensions. So scale factor is model over original, and that will simplify to 2/5. Okay, so the scale factor, this diagram is 2/5 aside, or 0.4 if you want to write it as a decimal. That is the same. Okay, the other one to look at is we are given the scale factor. We have a cylinder is enlarged by a scale factor of 5/2. What is the dimensions of the enlargement? So we need to find both the height and the width, or the height and the diameter of our new cylinder. This new cylinder, because it's an enlargement, is going to be bigger. I'll do my best to draw a cylinder. That's pretty bad. There we go. Alright, so we need to find our new height and our new diameter. Scale factor is model over original. This time we know our scale factor. And if we wanted to find our height, this is the height of our model. So that's going to go on the top. And for our original, our height was 5. So this is the equation that we set up. And this is the equation that we solved to find our new height. Okay, by multiplying both sides by 5. The 5 divided by 5 goes away. 5 times 5, we have 25/2 equals our height, or 12.5. Good. If we want to find the diameter, we follow the same process. 5/2, we use our scale factor. That equals our diameter, our model, over our original, which is 2. So now this is the setup for solving for the diameter. We have the scale factor on the left-hand side, which was 5/2, and we have the model dimension divided by the original dimension. The model dimension we don't know yet, so we use a variable. Solving this equation, we times both sides by 2 because it will cancel this out. It ends up canceling this out as well. And our new diameter equals 5.